4.3 Logarithmic Functions. So today we're going to talk more about logs. We're going to talk about the definition of a log, and we're going to learn how to convert from log form to exponential form. So the definition of a logarithm. If x is greater than 0 and b is a positive constant and not equal to 1, so b is the base of our log, and b will also be the base of our exponential or of our exponent. Okay, then the following. Y equals log base b, notice how it's a little smaller and lower, of x. So log base b of x, that's how we say it. If and only if b to the y equals x. So this is known as our log form, whereas this is known as our exponential form, and we should be comfortable converting from one to the next. And the way I convert from log form to exponential is I always start by circling my base, and that becomes my base in my exponential. Then we raise it to the other side of the equal sign, and that becomes our exponent. And then we set it equal to what's called our argument, x. And you can see that over here. Okay? Now, similarly, I could take and convert back to log form from exponential. So log base b, all right? I always start log, my base is at the bottom, okay? Of x, so we go across the equal sign, that's my argument, and then we set it back equal to that exponent. Okay, so we need to be comfortable going back and forth. So one thing we need to note is that f of x equals log base b of x is the inverse of g of x equals b to the x. Okay, so logs and exponentials, they are inverses of one another. So we can show that in this next step here. So we want to use composition of functions to prove that f of x equals log base b of x and g of x equals b to the x are inverses. So remember, if we're going to prove this, we need to use composition of functions and show that both sides, or that it simplifies to x, okay? So this first part here, f of g of x, okay? So what we're going to do is we're going to take our g function, which is b to the x, and we're going to plug it into our f function for x. So it's going to look something like this, okay? All right, so now all I'm going to do here is I'm going to change this whole side to be y. It's just going to be easier for us, okay? And now what we're going to do is we're going to convert to exponential. So remember, I have log base b. So my base is b. I raise it to the other side, and we set it equal to that entire argument. So that's where we get b to the y equals, our argument is b to the x. Well, since our bases are the same, we can go ahead and zoom in on these exponents here, and then we end up with the right side equaling x, which is what we wanted, okay? So now we just would have to do the reverse. We'd have to show the other way works as well. So now I need to take f and plug it into g, okay? So it's going to be b to the log base b of x. So this log base b of x is our power, okay? Again, I'm just going to change this to equal y just for ease. And now what we're going to do is we're going to convert. So when we convert, I start with my base. So it becomes log base b, okay? Log base b, that's this portion right here. We raise it to the other side, or sorry, log base b of y. That's our argument here, okay? And then we set it equal to our power, which is log base b of x. So now what we should notice is that we have a log base b on the left and a log base b on the right. So when this happens, we can zoom in and set those arguments equal. And so the right side simplifies to be x. Therefore, we can go ahead and say these are inverses. Now we're going to just get some practice going from exponential form to log form. So remember, with exponential form to log form, again, we start with our base. So if y equals log base b of x, we're going to convert that to exponential. So I start with my base, we raise it to the other side, which is y, and we set it equal to the argument. So that's where we get our exponential form. If we're going from exponential to log, again, I start with my base, and I say log base b of x. So that's this portion here, and we set it equal to y, and that's where we get our log form. So now let's just go through some examples, okay, of how did we get this. So in part A, again, I circle my base. I'm in log form. I want to go to exponential. We circle our base of 5. We raise it to the other side, and we set it equal to that argument. And that's where we get 5 to the third equals 125. Taking a look at part B, see if you can convert it. Identify your base, 6, raise to the other side, set it equal to that entire argument. So when you do that, you get 6 squared equals x plus 4. 6 squared is 36. 36 equals x plus 4, so we can solve this and get x equals 32. Try C on your own. Convert it to exponential form. Hopefully you got e to the third equals x. Go ahead and complete D on your own. Log base b of 5 equals, log base b of b to the 5th equals 5. Identify your base, raise to the other side, set equal to your argument. And what do you get? Hopefully you get b to the 5th equals b to the 5th, because I circle my base, raise it to the other side, that's this piece right here, and set it equal to that argument, which is this piece right here, b to the 5th. Now we're going to go from exponential to log. So it's still the same concept. I identify my base, I circle that. That becomes log base 2 of 8, that becomes my argument, and we set it equal to our power there of 3. So we get log base 2 of 8 equals 3. Now you try F. B to the 0 equals 1. Identify your base, all right, and go from there. Okay, so we identify our base, log base b of 1, that becomes our argument, and we set it equal to that power. You should familiarize yourself with some of these properties of logs. Now, these are just shortcuts, and we could always work our way around these if we didn't necessarily remember. So, if we have log base b of b, we can go ahead and say that equals 1. When the base of your log is the same as the base of your argument, you're left with your power. That kind of goes along hand in hand with this one right here, okay? If you take a look, our power in this one is simply 1. So it's log base b of b to the first equals 1, whereas down here, log base b of b to the x equals x. So when the base of your log is the same as the base of your argument, it simplifies to be the power of your argument, okay? All right, the next one, log base b of 1. When your argument is 1, this whole log really is just equal to 0, okay? Similarly to these red highlighted properties, if we're in exponential form and I have b to the log base b of x, I could go ahead and say that that equals x. So when the base of my exponent is the same as the base of my log within my exponent, I'm simply left with my argument, okay? And then some other properties. This is just called a common log, okay? Log base 10 of a is the same as saying log of a. When there's no base written in for your log, we know it's 10. Kind of just like with square roots. If I just have the square root of x, I know my index is 2. It's not written in though, okay? We would say our index is 2, but we don't write it in. Same with logs. When I have a no base written in for my log, I know it's 10. And then similarly, log base e is the same as saying ln, or natural log, okay? This is the more common way, seeing it as natural log of a. Seeing it as natural log of a. Your argument is a. When I see ln, I know that it's really just like saying log base e. My argument doesn't change. Anyways, let's use these properties for some examples. As we go through these examples, the first thing we can do if it says to evaluate each expression is I can certainly just set each of these equal to x, and then we can make some conversions, all right? Or we could use some properties. So I'll show you both ways, okay? So this first one, I'm going to zoom in, all right? Log base 10 of 1 equals x. Well, we can convert, okay? If we convert, we get 10 to the x equals 1. Well, how do I get something that's raised to a power to equal 1? What does x have to be? Well, our only option is for x to equal 0. But that brings us to our property, right? When our argument is 1, the whole thing equals 0. So really what we can do here is we can erase this x and we can just simply put equals 0. All right, what about b? Looking at our properties here, we should notice the base of our log is the same as the base of our exponent, or of our argument, sorry. So what does x have to be? Well, this should equal this right here, right? When the base of your log is the same as the base of your argument, you're just left with that power. Okay, so it should be 5, but one thing we can do, again, is we can do our conversion. So if I take my base, 3, raise it to the other side, and set it equal to my argument, which in this case, our argument is 3 to the 5th, now we notice, hey, when our bases are the same, we can zoom in and say, oh, well, x has to equal 5 here. Looking at part C, again, if we'd like to make some conversions, let's go ahead and do it. This is only going to help us when we get into solving further on, okay? Now, it doesn't look like it follows any of these properties, but maybe if we were to rewrite this cube root of 49, we might be able to notice something. So let's go ahead and just look at that aspect first. So the cube root of 49. All right, well, that's like saying 49 to the 1/3, right? Just going from radical notation to exponential. Okay, 49 stands out to me. 49 is a perfect square. So 49 is like saying 7 squared, all to the 1/3. Well, when we have a power of a power, we can go ahead and say, well, that's 7 to the 2/3. So if we just rewrite this, log base 7 of 7 to the 2/3. Now if we look at our properties, what do we notice? Well, we should notice that we have a log with the base of the log equal to the base of the argument. So what should this equal? Well, this better give us 2/3, right? We get our power there, okay? Now, the other way I could have done this, I'm going to zoom in, and if I have this equal to x, so I'm going to scoot this up here, we could convert 7 to the x equals 7 to the 2/3. Now that the bases are the same, we could do our zooming in and say, well, x has to equal 2/3, right? And that's what we got. So there's two ways you can go about it. If you don't remember those properties, we can always just convert it to exponential form. Looking at part D, we have 5 to the log base 5 of 8. What's that going to equal? Well, hopefully, if we take a look at this property right next to it, we're going to go ahead and see, oh, the base of our exponent is going to be the same as the base of our log within our exponent. So when those match, what are we left with? We're left with our argument. So this should just equal 8. Okay? For part D, we should notice that we have this ln, right? And what's another way to write ln? I'm simply going to rewrite it as log base e. I do not change my argument. My argument is still e to the fourth. Okay? So now this might help us as we look at our properties again. And I see, oh, the log, or the base of my log is the same as the base of my argument. That's this guy right here. The base of the log is the same as the base of the argument. We're left with that power. So this should just equal 4. Okay? If you have questions on this, we'll get lots more practice. Let's move on to graphing. So now we're going to get into graphing log functions. The first thing I want to do is, if we're in f of x notation, I want us to change it to y equals log base 3 of x. Okay? So we're going to change that f of x to y. It's just going to make our lives a little easier. So then the first step that we need to do is we need to convert this to exponential form. Okay? So when we convert this to exponential form, we take our base, we raise it to the other side, so we get 3 to the y, and we set it equal to that argument of x. And now what we're going to do is we should notice, hey, this is kind of like when we were graphing exponentials and we plugged in for x, but now since y is our power, we're going to plug in for y and we're going to solve for x. So I always start with the value that makes my power 0, and that's when y equals 0. All right, and then I choose values that surround it. So that's why I go and I plug 1 and 2 and -1 and -2 in for y. When we go through and solve it, these are the x values we will get. And what we should notice is, as y is getting more and more and more negative, what is x approaching? X is approaching 0. So this time we have a vertical asymptote, okay? We have this vertical asymptote of x equals 0 this time. So now we can go ahead and graph this. Now that's in pink, okay? So I'll talk about this blue graph in just a second. So we have our vertical asymptote at x equals 0. We can go ahead and plot those points, and we should notice that we get this curve here, okay? Now, remember what we said at the beginning of the video, that exponentials and logs are inverses of one another. So the inverse of 3 to the y equals x, remember we switch x and y, we get y equals 3 to the x. So if we were to graph this, I would plug in for x, or we would simply switch our x and y values in the table we found up above, and we're going to get these points here. And remember, we've got this horizontal asymptote at y equals 0. And what you should notice is, hey, remember, inverses are symmetric about the line y equals x, and they happen to be. If we were to fold that, they would match up perfectly. If you have questions, let me know. We'll definitely get more practice within class.